on is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Liftoff. 30 minutes after the hour. Mission Control, we have liftoff.
There we go. Okay, I had a little hiccup there. So, everybody, welcome. Welcome to the Tour of the Solar System, Part 3. I want to welcome everybody here. Everybody's currently in the chat right now. Yosef, Sci-Fi Guy, Pixelets. Welcome, guys. Last week, we talked about Jupiter, the 5th planet in the solar system. We've already taken a tour on the solar system, and we're already at Jupiter right now. If you haven't already, hit that little subscribe button below. I would highly suggest go ahead and do that because, well, you never know what could happen. And today, as I said, we are going to examine Jupiter and its many, many moons. Yes. There is currently 63 moons in Jupiter. It takes 83 hours, well, approximately 83 hours for light to reach from Jupiter to Earth. That means all the probes, the Cassini-Huygens, the Pioneer, the Voyager, they all had a long delay. So there was not an instantaneous one. It takes 29 and a half years to orbit the sun. That's a very long elliptical orbit here. Galileo Galilei, he first observed Saturn with a telescope in 1610. And yes, these are his actual images and drawings right here. You can see the first drawing is the little ears, and the second one was his arms. Of course, 2 years later, when he viewed Saturn, he saw that the moons had disappeared. And of course, another 2 years later, he saw the moons had actually returned, and thought there was some sort of arms. We know this because Galileo was actually viewing Saturn directly on. When you directly view on the plane, you don't see the rings anymore. Yes, agreed, Yosef. If you like a ring, yep, you should put a ring on it. Agreed, Yosef. That's why Saturn has rings. Oops. Wrong tab. There we go. In 1659, the Dutch astronomer named Christian Huygens, he saw the mystery of Saturn's arms. Yep. Just because of improved telescopes, he correctly deduced that the arms is actually a ring system. Yep, you should put a ring on it. As you can see with the detailed limit images right here, 1675, Cassini discovered a narrow gap in the splits of Saturn's ring system into two parts. It's known as the Cassini division. When you look at Saturn, you see one section ring, a spot, empty spot, and this section ring. That's called the Cassini division. I mean, there is the D ring coming out from outside, inside the planet to the outside. You have the D ring first, the C ring, the Cassini division, like I said before, the A ring, F, G, and finally the E ring. Of course, the E ring is very special because it's much further out, and it's very faint by Phoebe's ring. It orbits the Saturn's moon of Phoebe. It's way out there. And of course, Enceladus is mainly responsible for the E ring. We'll get to Enceladus in a little bit. Don't worry. As you can see, the Saturn's ring system, it extends about 175,000 miles out from the planet. That's 282,000 kilometers for anybody who doesn't use the metric system or who uses the metric system. Us Americans, we're stuck on miles. I know, everybody else uses the kilometers. Even NASA uses the kilometers. The ring system, 9 Earths, side by side, can actually fit inside the diameter of Saturn's rings. And of course, it takes about 10.7 hours for it to rotate on its axis. It's one Saturn day. And like I said earlier, it takes about 29 years to orbit to orbit the sun for one complete orbit. When Pioneer and Cassini examined Saturn, they found that the atmosphere is mainly made up of hydrogen and helium. That's H2 and He. And of course, it is very windy. The winds in the atmosphere reach 1,600 feet per second. That's 500 meters per second. And the strongest winds on planet Earth was measured about 210 10 miles an hour up in Mount Hood, I believe. And it was over 200 miles an hour in Mount Hood. As the rings extend out, you can see the Cassini division, the depth of the rings, along with the several different moons, Minos, Enceladus, Thais, Dion, and of course you have Rhea way out there. One thing about the Pandora, Saturn shepherding moon, Pandora, and the F ring. As you can see, as the moon orbits around the planet, the gravitational pull from the moon itself actually distorts the rings, as you can see in the image. It's called gravitational pulling. And of course, I love this picture because on April 2nd, 2017, at 10:41 PTD, Cassini was about 870 million miles away from Earth. And that little dot right there you see on the screen, this is Earth. Yes, I love that little picture. You know, Saturn's embedded moon Pan is actually inside the Encke gap of the A ring. As you can see, it's perfectly balanced right here inside, right in the center of the Encke ring, of the A ring. It's in the Encke gap. The way the gravitational pull is the many thousands and billions of ice crystals that are the size of pebbles, the size of houses, the buildings. They keep a nice little rotational pull on the moon right here, moon Pan, which keeps it in a perfect little orbit. Speaking of the rings itself, did you know that spokes are in Saturn's rings? Yeah. The ring system is not flat like everybody thinks it is. No. As you can see, the shadows that are pointing upwards here, these are high, tall pillars. We actually see the shadow of tall pillars of ice crystals and ice particles inside the ring. And many people want to talk about what we didn't see before, Saturn's hexagon. Yeah. There's a massive, huge hurricane just right on the top of the North Pole. It's about 50 times larger than the average size of a hurricane on Earth, which the wind speeds basically go about 2,000 miles an hour. Sorry, the span's about 2,000 miles. This little animation right here is a 1,600 step that follows smoothly at 60 frames per second. Thank you, NASA, for this, Caltech. They made a little movie of it, and the little dog going around was the position of the sun while the pictures were being taken, so you get a perspective of it. And here's a better, clear picture from Cassini itself, looking almost directly down at the hexagon itself. Actually, these are actual images, by the way. These are not computer-drawn images. These are all from NASA JPL, Caltech. I love the NASA science because they actually use real pictures. This is an actual movie composite here of the colorful view of NASA's mission. You can see for the first time it actually showed the color filters, and the movie showed the complete view from the North Pole down about 70-degree angle. And as you can see right here, the little vortexes, you can see one of my mouse is, the little vortexes right here, these are basically circumventing air among itself. They're not on the top of the surface, they're just below the surface of the air. That's what scientists are saying. A bit better example right here. This is the green spectrum. This is the red spectrum image from Cassini-Huygens itself. I was saying about the little storms. As you can see clearly right here, these little two storms right here, These little vortexes that basically causing the hexagon to fold in on itself. And hey, guess what? Saturn does have moons. Yeah, unlike our moon, Saturn has approximately 63. I got into a discussion yesterday about, isn't there 64 moons? Well, one of them is believed to be an asteroid that passed by that they didn't think that was actually in orbit itself. Because I'm not going to list all 63. That's just too long to do that. So I'm going to only talk about just a couple of them. For example, there's Mimos. We have the famous Enceladus people always talk about. We have Tethys. I can't pronounce that correctly. And of course, Dion, Rhea, and Hypatius. Picture of vortex is vortices. Thank you, Joseph, for that correction. Yes, thank you. I just want to thank you, Joseph. They're called vortices. Thank you. Here's an example taken actually from Cassini-Huygens. To the left are the small moons Janus and Pandora. They're about 179 to 81 kilometers across. And of course, right next to it is Enceladus and Mimos, the Death Star. It's, as you see right next to Rhea, not Rios, Rhea. And of course, cut up by the edge of the frame right here is Saturn's second largest moon, Rhea. I did say Death Star. Why did I say Death Star? Well, because we actually have our very own Death Star in our solar system. It's not an active moon, but it is a small moon. It's called Mimos. Yes. Covered in the crater, Mimos is the smallest and innermost of Saturn's major moons. It's not quite big enough to hold a round shape, but its low density suggests that it consists entirely of water ice. Accretion is what causes objects to come together to form bodies of planets. When something is approximately 300 kilometers across, that's when the gravitational pull of the object compressed it into a sphere form. That's why Mimos is not a perfect sphere. Or sphere, sorry. And of course, Mimos was discovered September 17th, 1789 by English astronomer William Herschel using just a 40-foot reflected telescope. Many people have differentiates between reflecting telescope and a refracting telescope. A reflecting telescope basically shows you the object in the inverted position. A refracting telescope bounces light off near to you, the actual images compared to your eye, reverted to your eye. It's less than 123 miles across, which is about 198 kilometers. And it's just over 115,000 miles from the planet itself. Mimas, why can't I talk today? I don't know. Lack of caffeine in my system? Maybe. Well, it takes about 22 hours or so to just make a complete orbit around Saturn. And like our moon, it is tidally locked, which means it does not rotate. It just completely goes around in a circle, in a circle, in a circle, in a circle. One of the most famous moons that Saturn has is called Titan. Titan is a very unique world with an atmosphere to it. On the left side, you can actually see what we actually seen from Hubble. This is what we can see with our naked eyes with a basic telescope. But when Cassini actually went to Titan and took a picture on May 6th, you can actually see the cloud covers itself, little forms right here. This right here is part of the methane lake. And we're going to talk about that methane lake. Because Titan is the only moon in the solar system to have an atmosphere, which is mostly nitrogen, like Earth. Unlike Earth, it's nitrogen, sulfur. I'm going to get into that. It's also larger than our own moon, because our own moon is about 138. I can't even read that. Sorry. I should have a little text right here. But this is from NASA's actual NASA EYES website. Moon comparison. You can compare Titan to different sizes of objects. I compared it to our moon since it is a moon. You can also compare Titan on the website to a school bus, an NFL stadium, different planetary bodies, even a scientist itself. Yes, to have a little figure of a human scientist, you can actually compare sizes to bodies with it. It's very cool. Very little interactive website. Titan, by the way, unlike Earth, is the only place in this solar system to have a liquid on its surface. Yet no other planetary body has liquid on the surface in our solar system except for Earth. And as you can see, this is an actual image from Huygens Cassini-Huygens. It shows a sunlight reflection of a hydrocarbon lake. I was just about to say that Mountains Elysium, the air is so dense and gravity is so light on Titan, if you strapped wings to yourself, you could fly exactly the air pressure. I think you're reading my mind, dude. Hey, we're on the same page. Right on. Some of the dust storms on Titan itself can reach up to 400 kilometers an hour or 250 miles per hour. These images here were taken using the visual and infrared mapping spectrometer on the Huygens Cassini probe. You can see different layers and different times they took it. May 12th, June 21st, you got June 28th. Different instruments were on the Cassini-Huygens. And I'm going to bring up the Cassini-Huygens in a little bit. So right now, we're just talking about Titan and its methane lakes. As you can see, when they used the image science subsystem radar map, they decided to do different topographics of the whole entire moon itself. It's covered in lakes, craters, dunes, hummocky, labyrinth, and plains. The most prominent feature on Titan is the plains. As you can see in all green right here, it is all the plains. And toward the center of the crater is where the dunes are. Dunes are created from tectonic forces or wind-drawn objects. And the blue lakes, yes, they even put lakes of blue on here. The Kraken Mar. The Kraken Mar is the largest lake on Titan. And we also have a couple prominent craters here. We have this little crater here, Mimuts. I can't remember the name of that exactly. I can't read it, a little too small. But there's some extra craters right here. Let's see. Some of the bodies of liquid are ethane and methane, like methane lakes. The brown part is the valleys, and right here is some of the lakes, right up here. The largest, like I said, is Lake Ligeia Mar. It is the second only size to Lake Kraken Mar on Titan. It's about 260 miles by 217 miles, and has a shoreline longer than 1,240 miles long. The shoreline is longer than the East Coast and West Coast, as longer than the East Coast of the United States. It's larger than Lake Huron and Erie put together. This is how large Ligeia Mar is. But I wouldn't go swimming in that lake because it's liquid methane. And people wonder, how can methane actually be a liquid if it's a gas on Earth? Well, it's so cold on Titan. Yeah, I wish it was cold. That the gas turns into a liquid, and it actually rains methane. That's why you have liquid methane lakes on Titan, because of the coldness. On January 14th, we actually took a look at inside Titan itself. The Huygens probe descended to the surface of Titan very, very slowly. As you can see in the top images right here, seeing the top images, this is what we always saw. We never saw below these cloud lines until January 2005. And as the probe descended slower and slower, you can see we have a little lake bed right over here. But the probe didn't land, just went straight on down. When it did land finally, we see rounded rocks. And every geologist on Earth has stated the only way you can get these round rocks is by a liquid. They didn't say water, by liquid. When liquid flows over a rock, it erodes it and makes it round. So there is right here proof that that liquid actually exists on Titan. Besides actual lakes, we actually have physical proof in the rocks itself. My second favorite moon, it's called Rhea. Not Rhea Perlman, but Rhea. Giovanni Cassini discovered it on December 23rd, 1672. Rhea right now, it is the second largest moon of Saturn, and it's only about 475 miles across. Like I stated, it has to be about 300 kilometers in order to condense into a round object. So Rhea is actually a round object. It is tidally locked, just like our moon, and it takes about 4.5 days or so to pass by. There's also something else about Rhea that people are not aware of. Unlike Titan, there is an atmosphere on Rhea. Yes, there's an atmosphere. It is known as an exosphere. It is basically composed of oxygen and carbon dioxide. It's the first time they actually directed spacecraft directly detected molecules of oxygen in the atmosphere other than Earth. Yeah. But of course, there's not enough oxygen for us to breathe or any of the life form that we know that can actually sustain the travel there and the lifestyle, except for tardigrades. But tardigrades is a whole nother story. Something unknown is causing a strange symmetrical structure in the changing particles around Rhea. Yeah, I mentioned this earlier. It's a little thin ring system. Yeah. But of course, I just found this out doing some research. In 2010, Cornell research associate Matthew Tiscanero stated this, quote, "There was a very strong and interesting and unexplained electromagnetic effects going on around Rhea, but we are making a pretty strong case that it's not because of solid material orbiting the moon." Yeah, just because it has a ring does not mean it's solid material. It could be a ring of particles, ion particles. They're still trying to get this after 10 years. After 10 years to discover this, still trying to analyze the data to find out exactly what these particles are. Are they small electrons? Are they small other kind of elements? But they're not a solid object. But it does technically have a ring, like Earth. Yes, Earth has a ring. Earth has a ring around it. It's artificial ring. So just because something has a ring around it does not mean it's ice or rocks or something. It could be anything that causes a ring around the planets. Oh, hey, guess what? We get to go to the most shiny object in the galaxy, in our solar system, actually. The most reflective body ever detected is Enceladus. Why is it reflective? Because it's white and the sun reflects white light. It was actually discovered by British astronomer William Herschel on August 28th. Whoever has a birthday August 28th, hey. It's only about 1,313 miles across. And it takes about 32 to 33 hours to orbit the sun, orbit around Saturn. And the average day around Enceladus is about 32.9 hours. This picture was taken by Cassini only about 25 kilometers from the surface. Yeah, that's very close, which is 15.66 miles of the surface of Enceladus. Let's see, what'd you say, Darth Hatsu? So we might be able to plant stuff there and produce oxygen. We might be able to, maybe algae or little types of fern, but right now, humans and animals like bunnies and hamsters and dogs, we cannot survive on that moon. Oops. Because Enceladus reflects so much sunlight, the temperature is really cold. Unlike Titan, it does not have methane cold, it has water cold. Yes, ice. Ice crystals. There is ice and water on Enceladus. It's so cold, it's 330 degrees Fahrenheit. That's minus 201 degrees Celsius. And here's another surprise. Cassini found a huge surprise for NASA and the rest of the world when it went down past Enceladus. What did they find? Anyone want to guess what they found when they passed by Enceladus? Nobody thought this was actually possible. But I'm going to tell you anyway. They found plumes. Yes, actual plumes of water vapor coming out of the moon itself. This right here is the changing views of the Enceladus plume. This little video here was brought to you by JPL. It was taken over 6.5 hours on May 10th, from a distance about 220 miles from the surface of Enceladus. And as you can see, as it rotates around, the actual plumes are coming down, which means there is an active geyser underneath the planet, underneath the moon. I don't know why I still want to call Enceladus planets. Well, because it does remind me of Earth a little bit. Thin oxygen, nitrogen, they have water, liquid water there. It's not too hot, not too cold. We can have suits to actually go there, to survive. But the only problem is we have radiation from Saturn itself. This picture right here was taken at 502,000 miles away. It captures the visible night light using Cassini's narrow angle camera. This is what really surprised people was the plumes, the active plumes on a moon. So awesome sauce. during the spectrometer, they actually did some analyzation, and these two maps right here look at what the color represents, the highs and lows. The purple represents the lowest elevation, while the red represents the highest. The highest elevation. Okay, let me backtrack here or forward. The left side, there was no up and down in space. But there is once you reach a planetary body. The red part right here is the highest elevation on Enceladus itself. Of course, with the lowest one being the purple elevation. And you can see the lowest ones right here is on the North Pole and right by the tiger stripes. The left one shows Enceladus as it possibly was about 1 million years ago. They have found evidence that actually tipped over like Uranus. A little bit on its, not fully on the side, but just tipped over. People are not exactly sure how it happened. Scientists are speculating it got impacted by a crater, by an asteroid or another small planetary body. But the thing about Enceladus is we cannot tell because there is no craters that are deep visible craters because the planet is always changing its surface. As you can see with the spectrograph, the top art is the 90-degree west. Yes, we're talking west from east, yes, because we are not in space. We're on a planetary body. The North Pole is completely void of any high elevation, but the South Pole is the hot spot. It's where the tiger stripes are. These are officially known as tiger stripes. And yes, they do have names, by the way. In the plume, they didn't just find water. They actually found salts, ammonia, methane, nanograins of silica, and other materials. Of course, they wouldn't have known about it if it wasn't being injected into space. If you're actually wondering about this picture, this was taken approximately 149,000 miles away from Enceladus. And that little dot on the bottom right here, this is the moon Pandora. Here are the names of the, yep, like I said, names have official, these are the official names of the stripes. This little plus right here means this is the actual South Pole. And going from the east is Cairo is this stripe. And this stripe is called Alexandria. The next one going southwest is called Baghdad, the longest stripe there is. I forgot exactly how long these stripes were actually measured, but there's no concise precision of measurements because they do change a lot. And the last one's called Damascus. Please don't ask me how or why they got their names like this. I'm not sure because normally planetary bodies have ancient Greek names or Roman names, but not city names. It's kind of odd. So if you want to help me do my research to find this out, please show me. Let's take a look inside Enceladus here. Global oceans on Saturn's moon Enceladus. I mean, you have the top ice crust, then below you have a global huge ocean, which scientists say is more water than there is on planet Earth. And in the center, you have a rocky core. But let's take a better look at how these jets actually can work. Or actually how they're supposed to work. You have the plumes coming up about 65 kilometers from the rocky core itself, going all the way up to the surface, and the pressure itself and the gravity of Saturn's pole is basically causing the moon to stretch and wane, which is causing the eruptions from the plumes in the South Pole. Some of the probes here that have visited Saturn and Jupiter was the first one was September 1st, 1979 was the Pioneer 11. They actually discovered the F ring and a brand new moon. Yes, and in 1980 and 81, the flyby Saturn Voyager 1 actually reveals the intricate structure of the ring system. It tells you how actually close they are. And that was actually verified by different scientists. If you want to skip ahead to 2017, they discovered a tiny new ring. It's the most outermost ring. It actually coincides with the orbits of Saturn's moons Janus and Epitheus. Like I said, there's 63 moons, a lot of different weird pronunciations of names, but help me out sometime, so. And of course, Cassini, the images on the left-hand side of the Voyager 1 Pioneer 11 probe, and the right side is a little diagram of the Voyager 1 probe itself. And speaking of going back to the Cassini-Huygens probe, on September 15th, 2017, Cassini ended its long 13-year mission. Yep. It plunged right into Saturn's atmosphere and took a sample of the atmospheric molecules. It sniffed the air, basically. Cassini had a very, very tough long mission. Cassini explored Jupiter, its many moons, Saturn, its many moons. They sampled atmospheres. They basically have, if Cassini was actually going to continue on, besides going to the planet, they couldn't really contribute that much because, well, not enough fuel and not enough time and money management. Hey, I want to thank everybody who was here for my little tour of the solar system for Saturn. And if you guys actually want to know what's up in the night sky for October, you guys can check this out. Mars will be closest to Earth on October 13th. It will glow reddish orange. Yes, reddish orange. And appear east in the sun. Yeah, east in the sunset. Oh, we're northeast west. And all you Oriented meteor shower freaks and geeks and nerds, October 20th and 21st. You're going to look east, northwest, south. Look up. You'll see the Oriented meteor shower. And if you're looking up on Halloween for the first time in 2001, there'll be a full moon on our sky. Yep. A full moon has not graced our sky since 2001. I actually do want to thank everybody again for being here. If you guys have not clicked that share screen or subscribe button, go ahead and do that right now. There's information in the bottom of the chat below down here. If you go to the description, you can see the websites from NASA, JPL, awesome sauce people. And I want to thank everybody for joining me. Next week, we are going to be talking about the other two gas giants, Uranus and Neptune. Or is it Neptune and Uranus? Well, they did change position once, and I will even talk about that. And we may even get into Kuiper Belt objects. Yes, Kuiper Belt objects, including Pluto, which has been deemed not a planet, but a dwarf planet. Yeah, a planet in a name that's not a planet. I personally would call them all Plutoids itself. So I want to thank everybody, and don't forget to hit that subscribe button and share, and let people know exactly, hey, what's up in the universe? Thank you for joining, everybody. Take care.